Hi, hello, my name is Kiran Kumar. I am your physics lecturer. Welcome to my channel Nature of Physics and Art. Today topic is applications of refractive index of prism. This is part 2 video. Before going to this video, please watch my part 1 video, that is refractive index proof of the given prism. Please watch my full video, then you can understand step by step. Now this is the refractive index of the prism mu, which is equal to sine a plus delta m divided by 2 whole divided by sine a by 2. Here a is the angle of prism and del m is the angle of minimum deviation. Here mu is the refractive index of the prism. That proof is already completed in part 1 video. Now here we will discuss Snell's law when light traveling from the rarer medium to denser medium, that is from the air to prism, and second, that is moving from the denser medium to rarer medium, that is we can consider as prism to the air. Okay, step by step we will discuss now. According to the Snell's law, here mu1 sine I, which is equal to mu2 sine r1. R1 is the refractive angle for the first refractive surface AB. Okay, I is the angle of incident. Okay, see here mu1 is equal to 1 and mu2 is equal to mu taken, then sine I divided by sine r1, which is equal to mu. For small angles, here sine theta approximately equal to theta, so we can consider here I divided by r1, which is taken as mu. Now I, which is equal to mu into r1, this is equation number 1. Okay, and light traveling from the rarer medium to denser medium, this is equation 1 from angle of incident, which is equal to mu into r1, we did from the Snell's law. Now here light is traveling from the denser medium to rarer medium. See now, that is mu2 sine r2, which is equal to mu1 sine E is the angle of emergent and R2 is the angle of refraction at the second refractive surface AC. Now here mu2, which is equal to mu, and mu1 is equal to 1, that is sine E divided by sine R2. For small angles, okay, sine theta is approximately equal to theta. Now here mu, which is equal to E divided by R2, from this equation A, which is equal to mu R2, is taken as equation number 2. Okay, so already we did 2 proofs in the relation, that is in the refractive index of prism. The first formula is R1 plus R2, which is equal to A, and second one del, which is equal to I plus A minus A. So here E and I value are replacing in this equation, then del, which is equal to I value is mu R1 and E value is mu R2 minus A. Now del, which is equal to mu common, that is R1 plus R2 minus A, but actually R1 plus R2, which is equal to, what is that, A is the angle of prism, then del, which is equal to mu into A minus A. Here del, which is equal to mu minus 1 into A. So this is taken as equation number 3. This is the relation between the angle of deviation and refractive index of the prism, and also a relation between the angle of deviation and angle of prism. Then based on these formulas we can discuss the relations step by step. Now the relation between the angle of deviation with refractive index and also angle of prism. Try to understand the relations. Now the basic equation 3 is completed, that is del is equal to mu minus 1 into a is the angle of prism and del is the angle of deviation and mu is the refractive index of the prism. For this first one, that is del is directly proportional to the angle of prism. See now here del is directly proportional to the angle of prism, that's why here angle of prism increases and deviation angle also increases. Try to understand. And second relation, here del which is equal to mu minus 1 into a and del is directly proportional to the mu minus 1 and del directly proportional to the mu, then refractive index of the prism increases and angle of deviation also increases. Angle of deviation also increases. Now third relation, here del is equal to mu minus 1 into a, and for this in dispersion deviation angle of violet is greater than to the deviation angle of the red, and wavelength of red is greater than to the wavelength of the violet color. That's why here wavelength increases and deviation angle is decreases. For example, red color wavelength lambda r is greater than to the wavelength of violet, then lambda increases, nothing but deviation angle of the red color is decreases for the red color. For violet color, here wavelength is decreases, that is deviation angle is increases. Now fourth relation, this is already completed in the first part video, that is I is equal to a, angle of incident is equal angle of emergent, and for this r1 is equal to r2 is equal to r, angle of refraction at AB surface which is equal to angle of refraction at AC surface. Now here del which is equal to angle of minimum deviation. For these conditions the deviation angle which is equal to angle of minimum deviation. Okay, in prism law of refractivity obey good, that is light traveling from the rarer medium to denser medium and denser medium to rarer medium, and also light can travel from the second refractive surface to the first refractive surface with same angles. See, this is the direction we can consider. Now A is the angle of incident and R2 and R1 taken as refractive angles respectively at the AC surface and AB refractive surface, and we can consider here I is the angle of emergent. That's why here law of refractivity obey in the prism is good. Now the maximum deviation angle of the prism we are going to discuss. For this, the light is traveling from the rarer medium to the denser medium, but angle of incident must be 90 degrees. So here I which is equal to taken as 90 degrees. Okay, so this is the path of the light exactly grazes the surface separation of the medium according to the law of refractivity which obey the critical angle. So here R1 is taken as angle of critical and here R2 is the second refractive surface and A is the angle of emergent. Okay, so here I is equal to 90 degrees and refractive angle which is equal to critical angle. Now we can discuss the derivation for the corresponding diagram. Now Here I is equal to how much taken? 90 degrees. Angle of incident is equal 90 degrees. This is incident ray. We can take P, Q is the incident and QR is the refracted ray and RS is the emergent ray. Now A we have to find. Before going to that, I is equal to 90 degrees and R1 is equal to theta C critical angle, and we can write the relation here. The first relation is R1 plus R2 which is equal to A. Okay, here R1 is equal to theta C critical angle and R2 is equal to A. From this equation R2 is equal to A minus theta C. This is taken as equation number 1. And try to understand second relation, that is second formula, that is del which is equal to I plus A minus A. Here del which is equal to I value is 90 degrees plus A minus A. Here E value we have to find from the Snell's law when light traveling from the denser medium to rarer medium. Try to understand. Now Snell's law, that is mu sine R2 which is equal to 1 sine A. Here refractive index of prism is mu and refractive index of air which is equal to 1. From this equation sine A which is equal to mu into sine R2 value which is equal to A minus theta C. From this equation we can write E is the angle of emergent, that A which is equal to sine inverse of mu sine A minus theta C. This is the E is the angle of emergent value. Now this is taken as equation number 3. Now equation 3 in equation 2, that equation del which is equal to 90 plus E value sine inverse mu sine, that is A minus theta C, and here minus A value. Now light is traveling along the normal direction of the one face of the prism, that is A B face, and this is the C. AC is the second refractive surface. See here I is equal to 0 and R1 also 0, because of along the normal direction there is no deviation, nothing but that travel in a straight line path, incident ray travel in a straight line path. Now here R is taken as R2, that is critical angle, and A is the 90 degrees, that is emergent angle which is taken as 90 degrees. See, and this is the deviation angle is del. Del is what here? Deviation angle. Okay, so now we can find the relations step by step. See now here I which is equal to 0, R1 is equal to 0 and R2 is equal to critical angle theta C and A is equal to 90 degrees. And first relation is, that is R1 plus R2 which is equal to A. From this equation R1 is equal to 0 and R2 is equal to theta C which is taken as A. So here theta C which is equal to A. So here critical angle which is equal to angle of prism. And also we can discuss the second relation, that is C del which is equal to I plus A minus A. Okay, see now, del which is equal to IA 0, A is equal to 90 degrees, angle of emergent is 90 degrees, and A is the angle of prism. So now del is equal to 90 minus A. We got two relations here with respect to given diagram. Now the values, based on that we can find the critical angle value, that is light traveling from the denser medium to rarer medium, that is mu sine R2, which is equal to 1 sine 90 degrees. That is sine R2 which is equal to 1 divided by mu. Then we can write mu is equal to 1 divided by sine R2. Okay, try to understand here the relation A which is equal to theta c we got, and which is equal to R2 is the angle of refraction at the second refractive surface. Now taken the values in the above equation, we will get the different equations. Then that is first relation mu which is equal to 1 divided by sine R2, and second relation mu is equal to 1 divided by sine R2 value is theta c, and third relation mu which is equal to 1 divided by sine A value. Okay, based on this equation we can write the R2 value which is equal to sine inverse of 1 by mu, and theta c which is equal to sine inverse of 1 by mu, and also A which is equal to sine inverse of 1 by mu. This is a very important concept. These questions are asking in the mains exam based on this relation. We did step by step complete derivation according to the when light traveling along the normal direction on the AB refractive surface of the prism. For second one, here light is traveling along the surface separation of the medium to the air. See, try to understand here I value which is equal to 90 degrees and E also 90 degrees. Then emergent ray also grazes the surface separation of the medium, and R1 which is equal to R2 which is equal to theta c. Then first relation R1 plus R2 is equal to A, and theta c plus theta c which is equal to A, and A is equal to into theta c is the relation. And second relation, that is equal to del which is equal to I plus A minus A, and del which is equal to 90 degrees plus 90 degrees, and A value is 2 theta c, and corresponding equation del which is equal to 180 degrees minus 2 theta c.